So I did the combination of Coulomb law, right? Plus equilibrium, and then the tension part. And we tried all sorts of questions. Okay. Now, this thing is then, so then this thing is added with some points, right? And we know that buoyancy is, so buoyancy force is, let's say if you have some liquid here and some object is immersed in this liquid. So this will experience an upward force, and that upward force is equals to the volume and the density of this liquid, right? And then this gravitational force of acceleration. So we will use this idea, and you will see another type of question that has been asked. Okay. So yes, so this is the question. You have two identical helium-filled spherical balloons, right? Each carrying a charge Q are tied to a weight W. With, okay, who left? Yes. So, and with strings and float in equilibrium. So as shown in the figure, we have to find the magnitude of charge, assuming that the charge on each balloon act as if it were concentrated at the center, right? And the second thing is that we have to find the volume of each balloon, and we have to take the density of helium as rho He and density of air as rho, right? Ignore the weight of the unfilled balloon. So only the weight comes from this air which is in the balloons, right? So this is Coulomb's law, which is added with this buoyancy force, right? So the first thing that we do, we have to write the free body diagrams and write all the contribution of the forces, right? So if we see this charge, so this charge is experiencing, so this is experiencing this tension, right? In this direction. And due to the weight, the tension is in this direction. Okay. Similarly, due to this weight, the tension is in this direction, and due to this charge, the tension is in this direction. Okay. And then you have this Coulombic force in this direction, right? And then you have this weight in this direction. Okay. And what is the uh, left force? What is the force that is remaining?
Charge.
Charge we considered, right?
Yeah.
The Coulombic force. The rest is this buoyancy, right? This is
Buoyancy.
so this is some right. So buoyancy, and you have also this gravitational force, right? So this has some mass. This has some mass.
So this is
yes.
buoyancy will be there when it is in fluid, right?
So this is immersed in the air, right? And this balloon has some helium filled air. So this will experience some upward force, right? This balloon. So this is a balloon which has some, right, helium filled balloons. Okay. Right, right, Chavez.
Yes, sir.
Yes, guys, I got disconnected, right? Okay. Am I audible, guys?
Yes, sir.
Yes, so I was writing. Yes, so I was writing the buoyancy force, the weight, right? And then you have this Coulombic force, and then you have this tension. So this angle is theta. So this angle is theta, right? So this is t cos theta, right? And then you have this t sine theta. Okay. So due to equilibrium, you will have this t sine theta, which is equals to this Coulombic force. And this FB is equals to this mg and plus t cos theta. Right, guys? So t cos theta is FB minus mg. Okay. Right, guys?
Yes, sir.
Yes. And now let us consider the free body diagram at this point. So this is the known quantity weight, and we equate all this equation with this weight. Okay. So at this point, we have this weight in the downward direction, right? And this tension has this component, which is t cos theta, right? And this tension has this component, which is also t cos theta. And this has the sine component, which is balancing the other sine component, right? So this weight, and we have 2t cos theta, we have this t sine theta, and we have this t sine theta. Okay, so weight is 2t cos theta. Okay, understood, guys?
Sir, can explain how it is 2T.
Yes. So you have two tensions, right? One is this tension and one is this tension, right? So this is theta. So this would be t cos theta for this tension. Okay. Again, you have this tension and this is theta. So this would be again t cos theta. Okay, so t cos theta will add up, right? And you have weight in this direction, and this is t sine theta, which is
Oh, okay, okay, sir.
right. Okay, so now we have this weight, which is 2t cos theta. So t cos theta is w by 2. Okay, and we have to find what? We have to find in the first part, we have to find, okay. So we have to find the magnitude of Q, right? So where is this Coulomb force coming, right? So this is coming in this t sine theta part, right? So we should not use this part. We will use this part and this part. Okay, guys. So for first equation, this is the first equation, this is the second equation, and this is the third equation. So we will compare the first and the third equation. So when we divide the first and the third equation, this would be tan theta, which is FC by W and 2. Okay. So FC would be how much? FC would be W tan theta by 2. Right, guys? Okay, my internet is unstable. Did I lag, guys?
Yes, sir, little.
Okay, I don't know why. So am I audible clear now? Am I clear now? Travis and all.
Yes, sir.
Okay. Yes, I think I think now the internet is. This is. Yes. So now we know what is this Coulombic force, right? The separation is 2x. The separation is 2x and the charges are QQ. So this would be simply KQ square by 2x square. And this is W tan theta by 2. So Q square would be how much? This would be W tan theta and 4x square by K into 2. So 2 cancels. And we have what? So this is W tan theta. K is 4 pi epsilon naught. And 2, so 8 x square. Root under. So this is our charge. Any doubt, guys?
No, sir.
Okay, so let us, so you guys just note it down and then we will do the second part.
Yes, sir. You can just show the question.
Oh, question. Yes, this is the question. So who is not here? Madiha is not here, and who else? Yes, so should I scroll down the screen?
Yes.
Okay. So whenever you guys are finished noting down, tell me, right? Then I will do the second part. So, guys, let me ask you this question. What is the medium here? This system is immersed in what?
Yeah.
Air. Correct, Shah. So this is in the air. Yes, noted, guys. So, who is teaching the CPSC course, guys? Amna ma'am.
Yes, sir.
Okay. So, whenever you came across the same question that I'm doing, which Amna ma'am has done before, so you guys just point, right? Because it happens that it may happen that I'll be doing the same problem that Amna ma'am has done. Okay, so please stop me doing that. because it will save your time, right? Yes, guys, noted. Everybody noted.
Yes, sir.
Chavez, and what about the rest of you guys? Everybody, guys, hello, mic check, testing. Yes. So Tarif, okay, yes, yes, you can note it down.
Sir, here distance of
So
string is L.
distance, yes, yes. So the length of the string is L, right? So you can see that this doesn't depend upon the, right? So in tan theta, yes, tan theta is also not. Yes, so Tarif, for Q, did we take K as 1 by 4 pi epsilon naught 0? No. You can see that for K, we take K is 1 by 4 pi epsilon naught, right? So 1 by 4 pi epsilon naught goes in the numerator. So it came here, right? This is the 4 pi epsilon naught and multiplied with this 2. So 8 pi epsilon naught. Okay, Tariq?
Okay, sir.
Yes, good that you asked question. So whenever you have that, please, please feel free to ask. Right, this is my job to clear it out. Because then, if I am not able to clear it out, then this is not justified, right? Okay, so done, everybody.
Yes, sir.
As I was saying, 1 minute. Okay, so. Yes, I guess everybody has noted. Right. So second part, in the second part of the question, we have to find the volume of each balloon, right? So whenever volume is associated, so we have to use this second equation, right? So we have to use this second equation, and we know that T cos theta is how much, right? So let us do this problem. Okay. So yes, so from here we should. Right, so let us use this. We have to find the volume, right? And volume comes in this part and in this mass part, right? So we have to use this second equation. And we also know what is T cos theta. So T cos theta is W by 2. So we will use this second and third equation. So T cos theta is W by 2, right? And FP minus mg. So how does this FB is related with this volume? So we already know that this is V and density of the medium, right? And gravitational force of acceleration, right? And then you have this. So mass we can write with respect to volume. So mass is density is how much? Density is mass by volume So mass is volume into density, right? And this density is given as this helium, right? So we are calculating the mass of the helium. So mass of the helium would be density of helium into volume. So rho He. Okay, so this is rho He Vg, right? So V is common, Vg is common. Rho A minus rho He, W by 2, right? So V is how much? V is W by 2G rho A minus rho He. Right, guys? Any doubt? So this was
No,
the,
sir.
yes. So this was the second question. Okay, guys, please note down this. Okay, I should write the second question. Yes, so please note down this part and then we will do the one more problem in buoyancy. Then we will do the spring problem and then we will do the one another problem. Okay, then we will start the electric field. Okay, this is again saying offline. So whenever you guys are finished muting, please tell me. Done, guys. This was
No,
three
sir.
of, yes, this was 3-4 lines, right? And rest of you guys, Shahid, Tarif, Faiza.
None, sir.
Yes, sir.
Yes,
Yes,
so yes. So the next question is this. You have two identical balls, each having a density rho, are suspended from a common point by two insulating strings of equal length, right? And both the balls have equal mass and charge, and they are at equilibrium, right? So each string makes an angle theta with the vertical. So this question we did earlier, right? Now the point is that now both the balls are immersed in a liquid, right? As a result, the angle theta does not change, right? So we make sure that the angle does not change. And the density of the liquid is sigma, so we have to find the dielectric constant of that liquid, right? So there are 2 points to remember. So 2 points are that if whenever you place some charge in the medium, so the force, the coulombic force change, right? It gets decreased by the factor of dielectric constant, right,
sir.
guys?
Is it epsilon of the medium by epsilon naught?
Yes, epsilon divided, yes. So your dielectric constant is, so E is ER epsilon or K epsilon, right? So you can also say this as the relative permittivity. So epsilon by epsilon. So K is epsilon by epsilon, right? So we have to find this K in respect to these questions, right? Not with respect to these epsilon by epsilon. We have to find K as the function of all these quantity that is mentioned, right? Okay, so yes, so what is the effective diagram? Yes, so I was telling that whenever you place some charge in some medium, so the force get decreased, right? You already know this. So F medium is F by K, right? Right, guys? This we know. And the second thing is that whenever you place the charge in some liquid, so this will experience some buoyancy. Right? So these are the two key points to solve this problem. Okay. So let us draw the diagram first. The diagram we have already encountered, right? So this is the diagram. Let's say R theta, right? And this is Q, this is Q. This length is L. Right, so we already know what is, so this is without the medium, right? So we already know what is F, so this is mg by tan theta, right? Or we have solved this problem, so this was what? So this was t cos theta, right? This was mg, this was t sine theta, and this was fc. So fc was t sine theta and mg was t cos theta. So fc by mg was tan theta. So fc was mg tan theta, right? So this we know already. In the previous question, we have done this. So fc is mg tan theta. Right, guys? Now this system is immersed in the liquid, in some liquid. Okay. So did Amna ma'am do this problem? Guys, can you tell me, did Amna ma'am do this problem? Yes, guys, am I audible? Guys, so did you? Yes. Okay, not sure. Okay, so if you are not sure, then let us do this problem. So then if this is immersed in the liquid, all the forces are the same, but you have one extra force, right? The tension is here. Okay, so Chavez is so the tension is here, and this is the theta. So this is t cos theta, right? And then you have this t sine theta. Okay, and then you have this mg, and then you have this. So now this is F medium. Okay, guys. And one more force is remaining. What is that, guys? One more force is there acting on this charge. Can you guys tell me? Yes, Shahid, Tariq, Faiza. Which extra force is acting? Because this is placed in some liquid, right? So this will experience buoyancy, right, guys? So we have this F buoyancy in the upward direction. Okay, guys, understood? Yes. So so the new diagram would be what? We have this t sine theta. We have this F medium. Right, we have this F buoyancy and then T cos theta. And then we have this mg. Okay, guys. So F medium is T sine theta. Okay. And in the second part, we have mg equals to T cos theta plus Fb. Right. So T cos theta is Fb mg minus f. Okay, guys. So t cos theta is mg minus fp. Okay. Now let us divide that. So this would give us so f medium by mg minus fp is tan theta. Okay. And we know what is tan theta. So tan theta is fc by mg. Okay, guys. And we also know what is f medium. So f medium is fc by k. And we have to find this k. So this is fc by k mg minus fp equals to fc by mg. So fc cancels, and take this guy in here and take these guys in here. So this would be mg and k mg minus fp. Okay, so k is how much? K is mg by mg minus fp. Right, guys? Yes. So now again, as in the previous question, we wrote m as v and rho g. Okay, and again this is v rho g, and we know what is buoyancy. So buoyancy is volume and density of the medium, right? And then g. So we can take vg common, right? And vg is common, so this is rho minus sigma. So vg cancels, and k would be rho by rho minus sigma. Okay, this is the answer. Any doubt, guys? Any doubt, guys? Any question, any doubt? Did Chavez came? Okay, so yes, so you guys please note down this part. Where should I put the screen? In here or where? Okay. Yes, Shahid and Tariq. What about you guys? You guys are not responding.
Yes, sir.
Any doubt or?
No, sir.
Okay.
No,
Nice.
sir.
Yes, so whenever you guys note this down, please tell me, then I will scroll down and put the screen where you need to write. Okay. Okay. So these are the different combination that may ask that, and there are a few other combination, and then we will try. We will learn about the electric field. Okay. So if you guys can recall, did Amna ma'am do the electric field due to finite wire and electric field due to charge, ring charge? So did Amna ma'am do that? Yes, guys. Can you tell me? So electric field due to this ring charge, right? And electric field due to this finite line charge. Okay, so you have this theta 2 and theta 1, and then you have this ex and ey. Right, so can you guys tell me, did Amna ma'am do these problems? Because guys, see, I don't want to repeat what Amna ma'am has done, right? Then you guys may get bored, and then you guys may say that what are you doing, sir? Right? Yes, Tarif, Shahid, and Faisal. Can you guys tell me? Okay, so whenever we reach that point, then you guys can tell. So should I scroll down the screen? Okay. Yes. Okay, so this part you need, right? Done, Faiza? Okay. Yes, what about Shahid and Tariq? Done, guys? Okay. So you see that this is rho by rho minus sigma, right? So this is not common. So if this would have been rho by rho 1 minus something, right? Let's say P. So then we can cancel. But there is some subtraction, right? So we can't cancel. So if you want to cancel, then rho, and we can take rho common, and this would be 1 minus sigma by rho. So then we can cancel. So this would be 1 minus 1 by sigma minus. Right. So, but that this much is okay, right? So we can't cancel like this. Like, let's say you have 2 by, let's say 2 minus 3, right? So this would be 2 by minus 1. You can't cancel 2 and 2, and this would be 1 by minus. Right, Tariq?
Yes, sir.
Yes. Okay, so before I do this question, you guys, so just take the screenshot of this question, and please, please send me this assignment. Okay. So we have 10 positive charged particles, right, are kept fixed on the x-axis at point x equals to 10, 20, and so on. And the first particle has charge A, and the second is 8, 27, right? So, and so on. The 10th particle has charge this. So we have to find the magnitude of the electric force acting on 1 coulomb charge placed at the origin, right? So these are some charges, right? So let's say Q1, Q2, Q3, right, and Q4, and so on. Okay, up to 10. And this is placed at the origin. Find the magnitude of the electric force acting on 1 coulomb. So 1 coulomb charge is placed at the origin, right? And we have to find the magnitude of force. So F we have to find, right? F net we can say. So that would be K Q1 Q2 by, let's say, R1 square. So K Q1 and Q, let's say 3. So KQ Q1, KQ Q2, R2 square, and KQ Q3, R3 square, and up to 10. So you guys have to calculate the magnitude, right? And you have to use this GP kind of thing. Okay. Understood, guys?
Yes, sir.
Okay, so just use that and try to solve this problem. Okay. Take in the screenshot, guys. Okay. Yes. Now let us do this problem. So in this problem, two identically charged particles are fastened to the two ends of a spring constant 100 Newton per meter, right? So K is given. This is 100 Newton per meter. Okay. And natural length 10 centimeter. So the distance is given. The spring length is given 10 centimeter. Right. The system rests on a smooth horizontal table. If the charge on each particle is this, right, find the extension in the length of the spring. Assume that the extension is small as compared to the natural. Okay. So we have to find this extension, right? And what do we know? So this is some spring, right? And some charge is, so some charge is, right? Some charge is fastened, right? So these are the two charges. Okay, and they are in equal magnitude, right? So they will try to repel each other. So this will shift in this x direction, x distance, and this will shift in this x distance, right? So we know that how much. So you know that this will experience some Coulombic force, right? And this will be equal to this restoring force. Okay, guys. Understood? Understood, guys?
Yes, sir.
So the force, Coulomb force would be how much? So this is 10 plus x plus x2x, right? So Fc and Fk is how much? This is simply Kx. Okay. So this would be how much? And Fc is K, and Q is how much? Q square by 10 and centimeter, right? So we have to change this in meters. So this would be 0.1. So this is 0.1 meter plus 2x square, right? This is kx. Okay, guys. And this k is different. So this is 9 into 10 to the power 9. And q is how much? 2 into 10 to the power minus 8. And 2 into 10 to the power minus 8, right? Divided by 0.1 plus 2x and square. And this is k is how much? 100 and this x. Okay. Understood, guys? Yes. So in this question, they are saying that assume that the extension is small as compared to the natural length, right? So we have to assume that this extension is very small, right? So this is very this, and this extension is very, very small. We can neglect, right? So we can neglect this part. So we have only 9 into 9 and okay, my internet is so into 10 to the power to 10. Okay, and this is 0.1 square, so 0.1 and 0.1. This 100 into 0.01, so this cancels. Yes. Am I clear now? My internet is somehow unstable. So am I audible clear now? Faisal and Shahid and Farid. Yes. Yes.
Yes.
Yes. So then we have what? So x would be, this is 8, 8, 16 and 9, 2s are 18, 2s are 36, right? So 36 into this is 16, so 10 to the power minus 7, right? So 3.6 into 10 to the power minus 6, right? And this is meter. Okay, guys, so this would be the extension. Now you can see that. You guys can see that this is of the order of 10 to the power minus 6. So that is why we neglected this part. So we have this 0.1 and the other one is 0.00035 and this is 3. So that is why we neglected this term. Okay, guys. Understood? Yes. So you see that in here, this Coulomb's law is connected to this spring force, right? Spring. So this was another combination that I wanted to tell. So, okay, so yes, please note down, and whenever you guys note down, please take. Okay. So whenever you guys are finished noting, please tell me. And give me one moment, guys. I am going to have some water. So. A diagram. So, Tarif, what do you want to say? Can I make the diagram again, or can
No,
I
sir.
explain the
Just
diagram
explain.
again?
Yeah, yes, explain.
Okay, yes. So you see that firstly, let us draw what was the preliminary condition. So firstly, you have two charges, right? And spring was connected, right? So, yes. So two charges were there and spring was connected, right? So this charge will try to repel, right? These are like charges, so this will repel, right? So this will come at this point, right? So this will stretch this string up to this point, okay? And again, due to this will also repel, so this will again come to this point, right? So this will have this x distance, right? So then what this spring will do, that it will pull this with the restoring force, this will pull this in this direction, right? So this Fk will be this Coulombic force. So is that clear, Tarif?
Yes, sir.
Yes. So did you guys note this down? Sorry, I went to have some water. Okay, noted everybody. Shai, then, yes. Yes, so now we have this question. So in this question, what they do is that they are associating this Coulombic force with friction, right? So you can imagine how much, so how many combinations are there. So this Coulombic force is then associated with some friction term, right? And you already know that the static friction is how much? This is mu n, right? Mu s n, okay. So we will use this relation in this question. So let us understand the question first. So you have a particle A moving a charge of 2 into is held fixed on a horizontal table, right? Okay, having a particle A having a charge of 2 into 10 to the power minus 6 coulomb is held fixed on a horizontal table. So this is, let's say, a table, right? And you have some charge at point A, right? So at point A, you have this Q charge. And a second charged particle of mass 80 grams stays in equilibrium on the table at a distance 10 centimeter away from this first charge. So at a 10 centimeter distance, another charge which has mass 80 gram, right? 80 gram is how much? So 80 gram is 0.08 kg, right? So 0.08 kg is held at equilibrium, right? The coefficient of friction between the table and this particle is mu, right? As 0.2. So find the range within which the charge of this second particle may lie, right? So the polarity of the charge is not given. They are asking about this range. Okay. Okay, guys. So they are asking about this range and the polarity is not given. So let's say, let's first consider that the polarity is plus Q, right? So this will have a normal force, right? Normal reaction. This has weight, mg, right? And this has a normal reaction m. And this charge will try to repel in this direction. Thus, this is the Coulombic force. Okay. So if this is the Coulombic force, what is the other force that is balancing this Coulombic force? Tarif, Shahid, and Faiza. Guys, please help me. So what is the force that is balancing this charge? The Coulombic force. Yes, Shahid.
Yes, sir.
Yes. So yes. Did you say anything?
No, sir.
Yes. So I am asking that you have this weight is balanced by this normal reaction, right?
Normal.
And you, yes, and you have this Coulombic force, right? So this is balanced by which force? Can you guess? Any guess, right?
Electrostatic.
Yes, static friction. Absolutely correct. Right, Tarif and Faiza. So this is balanced by, so this force is trying to take this charge here. So this is balanced by this static friction, right? Understood, guys? So this N is mg, right? And this Fc is Fs. So Fs is mu N, right? And N is mg. So mu mg, right? And this Fc is how much? So Fc is K, and Q square. Q is how much? Q is okay, not Q square, Q and this known Q. 2 into 10 to the power minus 6 and divided by distance is 10 centimeter, right? So 10 into 10 to the power minus 2 square, and this is equal to nu is how much? 0.2, and 80 into 10 to the power minus 3, and what is, so G is 10, right? Okay, guys. So K is 9 into 10 to the power 9, right? Into 2 into 10 to the power minus 6 divided by, so 10 and 10 minus 2, so 10 minus 1. So this is 10 minus 2, and this is 0.2 into 80 into 10 to the power minus 3 into 10. Okay, guys. So this would be how much? So Q would be 0.2 into 80 into 10 to the power minus 3 into 10 into 10 to the power minus 2, and divided by 9 into 10 to the power 9 into 2, and 10 to the power minus 6. Okay, so 2 and 10 and 2 cancels. Okay, and we have, so 9 and 6 is 3, right? So 3 and this goes, okay, so this is how much? So 80 by 9 into 10 to the power minus 5 into, this is 3 and this is minus 3. So 80 by 9 into 10 to the power minus 8. Okay, guys. So this is how much? 9. So this is approximately 9, I should say, but let us write what is. So, right. Okay, so 8.8. So we can write 8.89 into 10 to the power minus 8, and this is Q. Right, guys? So this was when we considered, this charge to be positive. Right, guys? So, but when we consider the charge to be negative, so when we consider the charge to be negative, so the Coulombic force would be in this direction, right? And the friction would be in this direction. Okay. So then you will find your charge to be minus of 8.89 into 10 to the power minus 8 coulomb. Okay, so the range would be how much? Range would be plus minus 8.89 into 10 to the power minus 8 coulomb. Understood, guys? Any doubt? Any doubt, guys? Shahid, Tarif, and Raisa. Any doubt?
No, sir.
Yes. Okay, so please note down this part, and then we will start the electric field. Okay. Done, guys. Okay. Okay, and Shahid and Tarif, what about you guys? Done?
Yes, certain.
Okay, now let us do this electric field problem. So the theory part you are doing, no, right? So this electric field is defined like, so this is F by Q simply, right? So this electric field for a point charge is how much? This is KQ by let's say R cube, right? And then R vector. So this is just like the force, right? So Coulombic force is how much? K Q1 Q2 by R cube, right? And then you have R vector. So if we divide by Q1, so let's say both the charges are same. So if we divide by Q, so this would be electric field. Okay. So the first thing about this electric field is the symmetry. So whenever you have this geometrical symmetry, right? So for geometrical symmetry, the electric field, so you will have some neutral point. Neutral point meaning that your electric field will be zero, right? So this is the neutral point. Okay, so let's say for lines and you have some equal charges. So at the midpoint of the line, right, let's say this is L. So at L by 2, this will be the neutral point. Okay. And let's say you have some triangle. So let's say if you have some equilateral triangle and at the centroid of this triangle, the electric field will be zero. Right. Similarly, if you have this square, right? So at the center of the square, this electric field will be zero. Okay. And similarly, you have a pentagon, regular pentagon. So at the center, the electric field would be zero. Understood, guys? So this is the symmetrical property of the electric field. Okay. Now there is one question that is being asked. So in this question, you have these 4 charges, right? And we have to find the electric field due to this 4 charges. So we have to find what is E1 plus E2 plus E3 plus E4. Right. So this is how much they want to ask. Okay, guys. And we know what? So we know that if there would have been another charge Q, so field at this point would have been zero, right? So if we know that E1 plus E2 plus E3 plus E4 plus E5 would be zero. Okay, guys. So E1 plus E2 plus E3 and plus E4 would be simply minus of E5. Okay. So the magnitude of this would be simply this, right? So E5. So this would be how much? So this distance is A. Okay. And so the electric field simply would be KQ by A square. Okay, guys. So this was a very simple question with the use of this this symmetric property. Understood, guys? Understood, guys? Any doubt? Am I audible? Yes. So please note down, and then I will do the second problem. Okay. Yes, Shai. So you are also writing in the chat box, right? Your mic is working. Okay, just quickly note down this part, and then we'll do one more. Okay, I gave you one question, and then I will give one more question. So 2 question, 1 week, right? You have 7 days to do 2 questions. So 3.5 days for 1 question. You guys, please try and send me. No, Tarif, we have to find what is E1 plus E2 plus E3 plus E4. We have to find what is the electric field due to this charge, this charge, this charge, this charge, this charge, right? So let's say due to this charge, this is E1. And due to this charge, E2, due to this charge, E3, due to this charge, E4, right? So what would be the magnitude? But we know that if we had some another charge plus Q, then field at this point from this symmetric property would be zero. Right. We want to calculate, so we want to calculate this much part. Right. So we put this in the left hand side and take this in the right hand side. Right. Then find the magnitude of only the fifth one. So this will be equal to all the 4 electric field, right? All the 4 individual electric fields. So this is the trick of the symmetric property, right? Understood, Tariq?
Yes, sir.
Yes, so now let us do this another problem, right? This is similar to the symmetric problem. Okay, so in this problem, a cube of side A has point charges plus Q located at each point of its vertices except at the origin, right? Where the charges is minus Q and the electric field at the center of the cube is what, right? So we know already, right? So at the origin, this charge is minus Q, right? So we know that if at the origin there was some plus Q, so the electric field would have been at the center of the cube because this is the geometrical center. So electric field at the center of the cube, if we had so if we had okay, this point, this point, this point, this point, this point, this point. So if all had been plus Q, right? So then at the center, the field would have been 0. Right, guys? But now you have a minus Q here. Okay. So you have a minus Q here. Then it is asking what would be the electric field at the center. Okay. What we can do is that we know the superposition principle. So the electric field would be the vector sum of the individual charges, right? So now we can replace this minus Q with this. So with this plus Q and minus 2Q, right? Let's say you have 2 charges. One is plus Q and another is minus 2Q, right? So at origin, you have 2 charges. Okay. So let us, so the electric field would be due to the combination of all these charges. But we know that for the case of this plus Q charges, let us forget about this minus Q part. So for the plus Q charges, the electric field would be 0. Right, guys? Now, what is remaining? We have to just calculate electric field due to this minus 2Q charge, right? So electric field due to this minus 2Q charge would simply be what? This would be K, and we neglect the negative charge when we calculate this electric field, right? So this would be 2Q, and what is, so this would be R cube, right? And then R vector. So this is the electric field, right? And now we have to know what is this R vector. So when you imagine this, let's say that your cube is your house, right? So let us consider your room as a cubic figure, right? So this center would be situated at half distance from the X, half distance from the Y, and half distance from this Z. The side distance is A. Okay, so this would be situated at this point, A by 2, A by 2, A by 2. Right, guys? Understood?
Yes.
This would be the center of this, yeah, so this would be the position vector of this, the coordinate points of this center of this cube. Okay, so the R vector for A by 2, A by 2, A by 2 would be how much? This would be A by 2 X hat plus A by 2 Y hat plus A by 2 Z. Okay, guys, understood? Oh, again, my internet is unstable. Understood, guys? Did I lag at some point?
No, sir.
Yes. Yes. So now we have to calculate the magnitude. So magnitude of this would be R, which would be A by 2 square plus A by 2 square plus A by 2 square and root over. So this is A square by 4, A square by 4, A square by 4. So this is how much? 3A square by 4. So this is root 3A by 2. Right. So let us plug in this value in here. So this would be how much? This would be 2KQ, and R vector is A by 2 X hat plus A by 2 Y hat plus A by 2 Z hat, and then divided by R is root 3 A by 2 and power 3. Right, so this would be how much? So 2 2s are, this is 8, and this 2 cancels, right? So this is this would be 3 root 3, right? So K Q and AX hat plus AY hat plus AZ hat and 3 root 3 and A cube, and this is 8. Okay. Understood, guys? So yeah. Okay. We have so we have this pi epsilon. So we can write 1 by 4 pi epsilon naught 3 root 3 AQ, and A we can take outside, so this would be 8 K, K is so Q A, and X hat y hat, z hat. So a cancels and 4 is 2. So 2 cube and x, y, z hat divided by pi epsilon naught 3 root 3 a square. Right. And this is also minus, so we can write minus. Okay, so this is the electric field. Understand? So this part, okay, and then we can end the class. Any doubt, guys? Yes, so you see that this charge is minus. So this was a minus 2q, right? When you calculate the magnitude, so then you can neglect the charge. But when you are writing in the vector form, so then you have to consider this minus. Okay. So whenever you're writing this in the vector form, you have to consider the minus. Okay, Shaya. Yes. We could take also a by 2 common in the denominator side. A by 2 where? So yes, in the previous case, we could have taken a by 2 common in the numerator, right? In the numerator, we could have taken a by 2 common. So in the denominator, you don't have. So in the denominator, you are saying a by 2 common. There is a cube here, right? So if you take, so that would be a cube by 2 cube. And this 2 cube goes in here. Okay. Okay, Tarif.
Okay, sir.
So in the next class, I'll be talking about the electric field due to ring charge and then electric field due to finite wire. From the Gauss property, Gauss's theorem, you already know about the electric field due to this infinite wire, right? Infinite charged wire. Done, guys.
Yes, sir.
Yes, Faiza and Shahid. Done, sir. Okay, so Shahid left, right? Okay, guys. So see you on next Thursday. Right. Bye, everyone. Allah Hafiz.